A severe mathematical conflict occurs when continuous fractional manifolds are forced to interact with discrete recursive topologies. The resulting mathematical intersection generates immense physical friction. Classical models frequently encounter this structural tension and dismiss it. Standard physics treats this resulting transcendental noise as an approximation error or attempts to manually erase it using renormalization, a collection of techniques designed to neutralize mathematical infinities that arise in calculated quantities. The theory of infinity, or TOI framework, treats infinity as an ontological primitive, an irreducible building block of reality. In this model, infinity functions as a dense geometric plenum stabilized by unbreakable laws. The ordered mathematical cosmos does not emerge from an empty set. Determinate structures, ranging from subatomic particle masses to macroscopic thermodynamic limits, are actively carved out of this infinite totality and locked into stable topologies. What traditional mathematics perceives as chaotic mathematical variance is actually structured thermodynamic heat. This heat serves a specific function, masking an immovable, discrete geometric bedrock. To accurately map the boundary between the continuous and the discrete, the TOI framework relies on the friction versus fiction protocol. This methodology strictly audits the thermodynamic and geometric tension that arises during mathematical boundary crossings. This protocol utilizes apophatic decompilation. Apophatic decompilation is a rigorous grading methodology that systematically strips away hallucinated computational artifacts to isolate true, unyielding geometric invariants. We will execute this decompilation process on a highly specific trigonometric equation. The objective is to expose the absolute physical boundary where discrete geometry arrests continuous fields. Mapping this boundary reveals that macroscopic thermodynamic systems are governed by singular, inescapable topological laws rather than random mathematical chaos. The target of this investigation is the canonical light witness. This is a highly convoluted continuous wave structure that was intentionally disguised within a complex trigonometric string to hide its true geometric mass. Applying the half-angle trigonometric identity, the continuous noise collapses perfectly, yielding the expression 4 sine squared of x minus the square root of 5 equals 0. This isolated constant, the square root of 5, is a discrete algebraic coefficient, the structural hallmark of a pure Fibonacci sequence. When evaluated under its baseline condition, set to 0, the equation outputs an exact real solution of 1.0673. This real spatial output perfectly replicates the established principal light root, confirming the equation's structural integrity in standard spatial dimensions. While the real spatial dimension holds up under standard analysis, the actual mathematical mechanics governing the universe are locked away inside the equation's hidden complex phase shadows. To locate the true physical roots of this hybrid polynomial, the analytical system must shift from the one-dimensional real number line into the two-dimensional complex plane. The complex plane is a coordinate system that incorporates imaginary numbers to map multidimensional geometric tension. The solver reveals an exact mathematical invariant. The complex phase boundary's real part doesn't float. It anchors permanently to exactly pi over 2. Defined as the orthogonal phase lock, this law ensures a continuous wave's spatial position is never altered by introducing discrete mass. This permanent anchor is dictated by complex arc-sine topology. The mathematical rules of the universe strictly forbid a real sine wave from exceeding an amplitude of 1. Therefore, the continuous golden wave is completely immune to amplitude scaling. Its real phase is locked in permanent structural steel, perfectly setting the stage for the ultimate stress test. To test the absolute physical limits of this pi over 2 phase lock, we engineer the singularity test, an extreme boundary shift designed to apply maximum structural stress. The test mechanics forcefully replace the baseline 0 boundary condition with the immense geometric weight of the 11th Fibonacci number, 89. Under standard mathematical expectations, dumping this massive topological weight onto a bounded trigonometric function should cause a total deformation of the wave, dragging its roots wildly off their established rails. In this chart, the real phase parameter, the pink indestructible wall at pi over 2, doesn't shift against the mathematical violence. Instead of bending the phase, the universe accommodates the massive load by violently shoving the baseline roots up and down the imaginary y-axis. This preservation mechanism defines the Phase-Amplitude Ejection Law. 100% of the newly introduced discrete mass is forcefully transmuted directly into imaginary amplitude. The complex plane functions as a physical thermodynamic exhaust manifold, absorbing the excess geometric weight that cannot be accommodated by real spatial coordinates. The phase-amplitude ejection law observed in these trigonometric waves maps to the mechanics of relativistic kinematics through the implementation of modality context chains. Standard quantum mechanics faces the Doppler energy dilemma. The measured energy of a photon appears to change arbitrarily depending on an accelerating observer's reference frame. This seemingly violates the universal law of energy conservation. The TOI framework resolves this by enforcing a conservation of modality. This law dictates that the energy lost during a cosmological redshift is never actually destroyed. Instead, the universe executes a modality lift. The missing source energy is actively transmuted into a form of potential energy, formally termed contextual tension. Contextual tension acts as a global invariant that preserves a photon's informational identity across all reference frames. The exact parallel emerges here. Just as the Light Witness equation ejects excess geometric mass into the imaginary plane, the macroscopic universe ejects lost kinematic energy into a latent, unmanifested dimension. This diagram shows where contextual tension goes. It's stored within the negative space of a toroidal cosmological engine, pulling the red arrows downward. Notice the cyclical flow. Kinematic redshifts act as macroscopic drains, transferring structural energy out of the physical volume into this vacuum reservoir. Inverting the Laplacian operator on the periodic ring of the toroidal engine requires a specific integration constant to satisfy the system's boundary conditions. The Laplacian operator is a mathematical tool used to calculate how a physical quantity, like energy, varies across a volume. This constant is Euler's basal value, pi squared over 6, which defines the finite capacity of contextual tension the vacuum can hold. Once the cumulative tension flux reaches this basal capacity, the engine executes a rebalancing event. This stored energy vents directly back into reality, manifesting physically as accelerated spatial expansion or localized white hole injections to maintain systemic equilibrium. From the decompiled roots of continuous trigonometric waves to the relativistic expansion of spacetime, the continuous fractions of reality do not bleed off into chaos. They are safely and permanently bound by the indestructible laws of discrete integers.